Welcome back to Matt Explains Science. Today we will continue with the theme of scientific notation, and we'll be looking at how to resolve some basic operations in the scientific notation form. Firstly, let's look at an addition problem. So, if we have a number written in scientific notation, and we want to add or subtract it to another number, also written in the scientific notation form, we just need to remember one thing. The exponents of the two numbers we want to add together must be the same. Okay? So, for example, n1 needs to be the same as n2. Let's see an example. Here we have the planetary system of Mars. Mars has two natural satellites, Phobos and Deimos. The question asks us, use the following data to calculate their combined mass. Phobos has a mass of 1.0659 times 10 to the power of 16 kilograms, and Deimos a slightly smaller mass at 1.4762 times 10 to the power of 15 kilograms. So note that the exponents are not the same here, so we need to make a little modification. In these addition problems, I always like to increase the exponent of the smaller number to match the bigger one, but it doesn't really matter which way you do it. What we do is simply multiply by a power of 10. A scientific notation uses base 10. So if we multiply by 10, we get 10 to the power of 16. But in order to keep the number the same value, we must divide the coefficient by the same power. So we divide by 10 here, and what that implies is moving the decimal one place to the left, giving us a value of 0.14762 times 10 to the power of 16 kilograms. Now let's take our two numbers that now have the same exponent and add them together. In addition problems, when you add them together, the exponent remains unchanged. And then we are left to add up the coefficients in the traditional manner. So 0 plus 2 is 2. 9 plus 6 is 15. Don't forget to carry the 1. Then 1 plus 5 plus 7 is 13. Again, carry the 1. 6 plus 4 plus 1 is 11. Then 1 plus 0 plus 1 is 2. And finally, 1 plus 0 is 1. This gives us a total of 1.21352 times 10 to the power of 16 kilograms. Therefore, the combined mass of Phobos and Deimos is 1.21352 times 10 to the power of 16 kilograms. And there you have it. Now we can continue with an example using subtraction. So subtraction problems are very similar to addition problems. Just a reminder, you can add two numbers or subtract two numbers in the scientific notation form, but only if they both have the same exponent, i.e. if n1 equals n2. So another example, A soil sample was dried at 70 degrees Celsius for 24 hours to remove the water content. So we need to calculate the mass of water that evaporates from the water sample after 24 hours. The empty crucible has a mass of 6.09100 times 10 to the power of 2 milligrams. The soil sample has a mass of 1.00052 times 10 to the power of 4 milligrams. And the dried mass of soil plus the mass of the crucible is 9.88080 times 10 to the power of 3 milligrams. So we can see that the crucible sample is lighter after heating due to water loss, but by how much we do not know. But we can use the following equation to work it out. The mass of water corresponds to A plus B, which is the mass of the original soil sample, plus the crucible minus C, which is the mass of the crucible and soil after heating. We should tackle this question in two parts. Firstly, A plus B, and then the second part will deal with the subtraction. We have the mass of the soil and the empty crucible, but they have different exponents, so we need to make an adjustment first. If we multiply the exponent by 100, we will get 10 to the power of 4. And to keep the number the same, we must divide the coefficient by 100 and shift the decimal point 2 places to the left. This gives us 0.06091 times 10 to the power of 4 plus 1.00052 times 10 to the power of 4. When we add them together, the exponent stays the same, and then all we need to do is calculate the addition of the coefficients. Starting with our 100,000ths column, 1 plus 2 is 3. Then 9 plus 5 is 14, carry the 1. 1 plus 0 is 1. 6 plus 0 is 6. 0 plus 0 obviously is 0. And finally 0 plus 1 is 1. Giving us a value for A plus B as 1.06143 times 10 to the power of 4 milligrams. So now let's look at the subtraction part. With A plus B now known, we can complete the equation. With the subtraction of C, except again the exponent is not the same, so let's just quickly modify it by multiplying the exponent by an order of 10 and dividing the coefficient by 10 too. Now we can continue. So 1.06143 times 10 to the power of 4 minus 0.98808 times 10 to the power of 4. This gives us the same exponent in the answer. And now on to the subtraction of the coefficients. Borrowing from the 10,000ths column, 13 minus 8 is 5. Then 3 minus 0 is 3. Again, we borrow from the hundredths column to get 11 minus 8 with an answer of 3. Here we need to convert our 1 into 10 tenths, and then borrow a tenth to get 10 100ths. And now 15 minus 8 gives us 7. From here, the rest of the subtraction gives us 0. And there you have it. 0.07335 times 10 to the power of 4 milligrams. However, we can't leave a number smaller than 1 in scientific notation, so we need to change this. We move the decimal 2 places to the right by multiplying the coefficient by 100, and also divide the exponent by 100, giving us 7.335 times 10 to the power of 2 milligrams. So the mass of water lost after 24 hours is 7.335 times 10 to the power of 2 milligrams. So thanks for watching, and see you again soon. Like and subscribe for more content. Thank you very much.